Instructions say to find the sum of a geometric series or state that it diverges. Okay. So we need a formula for this thing here. Some sort of n formula. Looks like it's always 4 up top and always 5 on the bottom. Do you agree with that?
Yeah.
So it's like, okay, 4 over 5. And then let's just say n starts at 1, although it could really start at anything, but let's start it at 1. This becomes n plus 2.
Okay.
All right. So that's where you got to if you tried this problem. You then have to say, okay, I have to write this differently. I have to write this as 4/5 to the n times 4/5 squared. Because when the bases are the same, you add the exponents.
Is the n plus 2 just like from the formula?
I made this up. Like I made up that if n is 1, it makes the first one, and then when n is 2, it makes the 4.
Okay.
I made this up. Like if you want to start at n equals 3, you can, but generally I start at n equals 1.
Okay.
So is the conversion clear? Because that's a big step here. If you're not.
Yeah.
Okay. So the summation of n equals 1 to infinity for an infinite geometric series is a1 over 1 minus r. Absolute value of r has to be less than 1. Okay.
Right.
So if it's not clear, this is r. This is always r in these things. If you can get something to the power of n, that's your r, whatever's inside there.
Okay.
So we have r. R is equal to 4/5. Now we have to find a1. Well, it's kind of already given. This is a1 up here, the 4 to the third, 4 to the third, 5 to the third, which is 64 over 125. So your summation, your infinite sum, is a1, 64 over 125 over 1 minus 4/5.
And then you would use a calculator for
Yeah,
that.
so it becomes 64 over 125 over 1/5, 64 over 125 times 5 over 1. So one of those cancels one of those, and you get 64 over 25.
So it convert it in like limit notation. It would be like limit of the.
So this we know that this. Okay, so I see what you're trying. I think I understand what you're trying to ask me. So there's like the first thing you generally find is like what is the limit? What is the limit as n goes to infinity? A sub n.
Yeah.
Okay, and that it comes from well.
Well, just like how would you write the answer in limit notation?
There is no answer. It sums. It's a sum. This one's asking for a sum.
Oh, okay.
Yes. Okay. Now there's some problems where this does not go to 0. If this does not go to 0, then it diverges.
Well, but wouldn't this one converge though?
The sequence
Like,
converges to 0. Go ahead.
Oh, sorry. Doesn't it converge to like 64 over 25?
The sum of the series. So you have to be very careful. There's two words. There's sequence and there's a series.
Okay.
Okay. The sequence in this problem, it converges to 0. The series sums to 64 over 25.
Okay.
Okay, and it's possible for a sequence to converge to 0, but not sum. So there's all these different things that can happen.
Okay.
And I know this is new language and all that. So generally, like the first thing you'd figure out is, does it converge or diverge? And then if it converges, can you figure out what it converges to?
Okay.
So like for example, and hopefully your instructor covered this, sigma 1 over n from n equals 1 to infinity, a sub n, it definitely goes to 0, but sigma a sub n is undefined.
Okay.
We don't know what this sums to. But we know it goes to 0, but we don't know how to add them up.
Okay.
It's
So
a
these
big,
are
which
These
is a
are
bit perplexing.
geometric series. Is that what these are?
Yes, yes. All these are geometric series.
Okay.
So geometric series, some of them do have infinite sums, but not all.
So you wouldn't say converge at all. You would just give 64 over 25.
Well, you can say, okay, so you can say that a sub n converges to 0, but sigma a sub n goes to 64 over 25.
Okay. All right.
I mean, this is a big deal, but I don't know how much we need to get into this because, but I just want to say,
Well, can you just write like 60, like you do your sum and you write 64 over 25
yes,
and just write next
yes.
to it like converges?
I mean, it's not right, but it's not wrong either. It's really, it's right in the middle. It's got some elements of being
Okay.
right, depending on your instructor. I think yours is pretty particular. She would probably say this is wrong,
Okay.
but it's true. It's kind of true.
Okay.
So I want to just briefly give this example. This is geometric, okay, but it does not converge because the limit as n goes to infinity, 5 over 4 to the n, does not go to 0. But this is geometric because it has the r equals 5 over 4. So not all geometric series converge. Some do, some don't.
Wait, before we do any more of these, can we
Sure.
do on the very first page of the packet, like one or two of these, like evaluate the limit ones?
Sure.
7 or 11 through like 22 on the very front page.
Okay. Yeah, these are very different than what we were just talking about.
Oh, they are? Okay.
But they're helpful. I mean, this is all related, but it's maybe all out of context for like what you want to do. So yeah, but let's do 11. Let's do a few of these and see if you, because these are functions, and functions, if they're continuous, they always have a limit. You know, for lack of a better like understand, this is 3 plus square root of x. It looks like a graph like this, and at the most basic way of understanding what a limit is, you just put this number in for x. So the limit is 3 plus the square root of 4, which becomes 5. So the most basic unit of a limit is you just try the number. But there are times when that does not work, which is what makes limits. Go ahead.
Isn't there like, can't you like separate, like write like, is that what you're supposed to do? Like separate them, like limit x approaches 4 of 3 plus limit.
Yeah, so you can definitely do all this. So you can say the limit is x approaches 4 of 3 plus limit as x approaches 4 of x to the 1/2. You can absolutely do all that.
And then you apply it. Okay.
Yes. This all gets covered again in calculus. So if you're taking that extra, I think you mentioned you are, then you'll just see this again. All right. So here again, the most so there's all these properties. Like you can say the limit as x approaches 1, 5 minus x squared all over limit as x approaches 1, 4x plus 7, and then you can break apart each of these if you want. And this is like it's what you're supposed to do, but it's very clumsy because it's a lot of writing because you end up doing the same thing. You just put the number in.
Okay. So just literally plug it in. Okay.
Yeah, for most of them. Now, like, see, like even this one down here, this becomes the limit as x approaches 1 of 4 times limit x approaches 1 of x multiplied. So it's I guess I vaguely remember doing this in a calculus class at some point. It's very tedious.
Yeah.
Okay, so we should do one like 14, where when you put 1 in, you don't get or you put the value and you don't get a nice number.
Okay.
Because this is the first maybe exam quality question you might see, or quiz quality question. So if you put -1 into the bottom, what happens? What does the bottom become?
0.
0. So it's undefined. So you can't do that. So you generally have to, and this is why you learned all this stuff before now. You have to do some algebra. In this case, you have to factor. So we're going to factor the numerator. So all that time you spent learning to factor pays off here. Okay. And when you factor, you realize, oh, I can cancel these factors. So this problem becomes the limit as x approaches -1, 3x plus 1. And then you go back, you just go back to putting that number into the function.
Wait, can you go over how you factored the top?
So the correct way is to use is to multiply 3 and 1 and make find factors of 3 that add up to 4 and then do grouping. But you're just trying to find, because 3x squared only has 3x and x as possibilities, you just guess and check on those.
Okay.
To do that.
Okay.
All right. And then you just put the number in and you get 3 times -1 plus 1. -3 plus 1 is -2.
Okay.
And then we should do one like 15 or 16. I probably have to do them both, but 15 is probably a better starter problem to do on these. Okay. If you put 9 into the bottom or the top, you get 0 over 0, and that's bad. Okay, like that doesn't work. So the previous problem I said to factor, and then this problem you have to do something that's non-obvious, meaning I have to tell you what to do to be able to do this.
Okay.
And you end up having to multiply the top and bottom by the square root of t plus 3, square root of t.
Oh, this is like the conjugate stuff?
Yes.
Okay.
Yes. You would never know to do this in a million years. I don't know. But they did these. This is a classic exam question that you would see. You would see something like this. So up top, when you FOIL, okay, and it's okay if you FOIL up here, you get t 3 square root of t minus 3 square root of t. You get t minus 9 up top. On the bottom, you get t minus 9 square root of t plus 3. And look at that.
Yeah, those cancel.
They cancel. So you get the limit as t approaches 9, 1 over square root t plus 3. And then you can actually put that number in. So it's 1 over square root 9 plus 3, 1 over 3 plus 3, which is 1/6. Again, non-obvious. There's many other problems where there's non-obvious things to do until someone tells you to do them.
Okay.
How far down this list do you have to go to satisfy your instructors?
She just said try a few from 11 to 22, but like I'm not giving this to her anything.
16, I'll just say 16 is like 15, except it's it's different multiplication, but it's the same idea. 17, 17 is like 14, where you have to factor and cancel.
You just do you just take out an x on the top?
Yes, but then you get x squared minus 1. You factor that, difference of squares, and then 19 is like the one we just did, except you're multiplying by square root t plus 3 top and bottom, and then cancel. So I'm happy to go through as many of these as you want. 21. Go ahead.
Yeah, I was just gonna say, why is there a plus after on 21, like -1 plus?
Okay, so this has been held back from explanation. So the definition of a limit requires you to look at the limit from the left and from the right. And this plus means, in words, it means from the right.
Why did none of the other ones? Like I've heard that before, but why did none of the other ones have that?
So I'm going to make I find this explanation is somewhat clear. There's a bridge here. This is a bridge. And in the best possible scenario, a road leads to that bridge. And then on the other side, there is a path the other way. Okay. Now, a one-sided limit always exists. And let me show you what that means. So one-sided limit is, here is my path. Okay. But it ends right there. That's a plus. That's from the left.
Okay.
Sorry, from the right, okay? And so you can imagine a function, a curve there. Let's draw it in blue. Let's draw one in blue here. This is from the left.
Okay.
Okay. Does there have to be a bridge between them? Like, do you have to, is every point always here? Sometimes can you have what's called a hole?
Yeah, you can
You've
hold.
seen it. Oh, so the one-sided limits always exist. Like if you think about, I'm a traveler going this direction, or I'm a traveler going the other direction. These things always exist.
Okay.
But the only in the best case scenario is are they the same value from the either side? So in this particular one, the graph of 1 over x plus 1, we have to look at what that actually is. Oops, let me get that. So 1 over x plus 1, there's a vertical asymptote there. Looks like that, and looks like that. Okay, so now this is asking at -1 from the right. So from the right means coming this way. So it says as you're coming from the right, I gotta keep drawing this to see it. What is this approach? This goes to positive infinity. So the limit as x approaches -1 from the right, 1 over x plus 1, it goes to positive infinity. Now let's look at the other way. What's the limit as x approaches -1 from the left? So from the left means I'm coming from the left. Hopefully you're seeing this. From the left, and it goes to negative infinity.
Okay.
Do these approach the same value?
No.
No. So the limit as x approaches -1 does not exist because they do not approach the same value.
Okay.
But a one-sided limit always exists.
Okay. But just if they're together, it doesn't exist.
That's right.
Okay. All right. That makes sense. Oh, that's why they say if not determine whether the one-sided limit exists.
Yes.
Okay.
Yes.
So those are both finite.
They can approach affinity and exist, which is a little odd, but because affinity, it's
no,
like
they're infinite.
yeah,
Okay.
you can or they can approach a numerical value.
Okay.
Okay, does that and that's hopefully now you say okay, it makes sense. Matthew said it doesn't really what we're doing with series isn't really the same.
Okay. We can go back to the series now.
Okay. There is sort of an infinite limit, but we didn't really get to that. Okay, so we left off on 24. Can I go to 26?
Yeah.
Okay. All right, so the first thing we talked about is like you have to kind of rewrite this. And the way to do that is you really want to have this as something to the power of n.
Okay.
So in this case, it's going to be -3 over 5. You can imagine if you apply the n to both of these, you get this, and then the 7 is out in front. So now the 7 can even come out further.
In front of the.
Yeah, so it's and I think this is sometimes used. So it's 7 sigma n equals 2 to infinity
Okay.
-3/5 over n to the n. So what you do is you find the sum here, and then you multiply it by 7.
You multiply the -3/5 by 7.
Well, whatever the sum is, we're going to find the sum of this.
Oh, okay.
So the sum of this, the sum is a1 over 1 minus r. Okay, and then we have to figure out r. Well, r is this thing in here. So So it's 1 minus 3/5. And then we have to figure out the first term. So first term doesn't mean A1. It means just putting 2 in for whatever the very first thing is. So you have to put 2 in. It's really A2 this time.
Okay.
Okay, so
Wait, how do you know if it's how do you know that's A2?
it says it starts at 2 for some reason,
Oh,
but
okay.
that's just the way the instructor did it.
Okay.
Um, and then so that you're just putting 2 in for n, so that's negative 3/5 squared, so that's 9 over 25. That's your A1.
Okay. And then you just
So it's 9 over 25ths over
1 plus.
1 plus 3/5, and then
So then you make common denominator. No. Yes.
you flip. So that, like, this down here is 8/5, and then
Well,
so
you
it's
have to make
not.
the common denominator on the bottom.
Yeah, 5 over 5.
Okay. 9 over 25 over 8/5, right?
Yes. And then you can multiply by the reciprocal on the bottom, so it becomes 9 over 25 times 5 over 8.
Oh, okay.
So it becomes 9 over 40. But then you have to remember to multiply by that 7.
Okay. So then it would be 7 over 1 times 9 over 40. So then can you cross multiply?
Yeah, so 7 times 9 over 40, so 63 over 40.
Oh, yeah. And then that's the sum. Okay.
That's it. That's your answer.
Okay.
All right. So can we move to 27? Oh, did you already do 27?
Yes, I did 27.
Okay, we can do 28 if you'd like.
Yeah, sure.
All right. So got this one here. This is a geometric series. We know that r is equal to pi over e. Is this less than 1? So this is where you got to be like, well, what's pi? 3.14. What's e?
2 point something.
Yeah, so this is actually greater than 1.
Yeah.
So this diverges.
Oh, so you don't have to do anything. Okay.
Yeah, there's nothing you can do here.
Okay. Cool.
So that one's done. But if it were e over pi, it would converge, and then you would have something different to do on that. Okay, so how about 29? Let's look at 29. Okay, so this is the part that's problematic, this e to the minus n, because you really want it to be something to the n.
E to the minus n.
Exactly. Or e to the minus 1, sorry, which is 1 over.
1 over e.
Yes, and that is definitely less than 1.
Yes.
Okay, so this is 1 over e, this is your r, so this one converges. So your sum is a1 over 1 minus r. Okay, your r is 1 over e. A1 you get by putting 1 into this. Okay, so you're putting 1 in here, so you end up getting the same thing as r, which is possible. So A1,
Is A1 1 over e?
yes.
Okay.
And it's okay that they're the same, like that can happen. And now it's just a matter of, like, can you simplify this? Is this something you're comfortable doing? And no, I can help here if you'd like. So you have to make a common denominator with e on the bottom. So it's E over E minus 1 over E.
Nah, I don't know how to do this.
Okay, so on the bottom here, it's just E minus 1. So 1 over E, E minus 1 over E. Okay, the E's cancel, and you're left with 1 over E minus 1.
And there's nothing else you can do from there.
That's it.
Okay. Very cool. Maybe we can do maybe one like 35 where they don't have the same.
Yeah, 35 is good to do because you have to come up with a formula and see if the formula it works. Lot going on 35. So yeah, look at that next. I'm glad we're doing this. I rarely get to do a topic like this with students. Seriously. So this is where it's like, if I tell you the answer, that's fine for this, but like, how good are you at coming up with the formula for this? Like, do you see the patterns? You see any, like, can you give me, I don't know, one or
Well,
two
like on
things
the
that you see?
top, it's squared, right? Every time.
It goes up by, like, it's power 1, power 2, power 3, power 4.
Okay, like 7 to the third, right? Is that what you're saying?
Well, it's like n on top.
Well, it's
It's like,
like 7 squared is 49.
right, and 7 cubed is 343.
Yeah, okay, that's what I was saying, but it didn't come out that clear. And
Okay,
then on the bottom, it's the same with 8.
yeah, so it's 7 over 8 to the power of n, but what else do you notice here?
Negative,
Yeah,
positive, negative, positive.
yeah, so that can be a little bit tougher to decipher because it's not negative in the first one. So you can do a few things, like you can put -1 out here and make it n plus 1, and that'll do some things. I don't know how comfortable we are with that, but that would do some things. You could start this thing at 2 instead, which is probably a better option,
Okay.
and then make this n minus 1. Oh, I'm sorry. No, that doesn't work either. Nope, that doesn't work either. So it's a bit of game here. How do you get this thing to do what you want?
Can't you just like put a plus minus in front of it? I don't know.
You can't. You have to actually account for it. So this is the way you alternate negatives.
Okay.
So this is one way, and then another way is -1 to the n. But this produces negative plus, negative plus, negative plus.
And you want plus negative, plus negative, plus minus, plus minus.
Exactly. So the other one, -1 to the n plus 1, or n minus 1 produces plus, negative, so on.
Does it matter if you put plus 1, negative 1?
It does, because the first one is positive. That's why I was giving you these two options in general. So like this one is -1 to the n
No,
plus
on
1.
option 2, like when you, oh, I see what you mean. Okay. Good that we're going over this because I never learned this in class.
Yeah, probably because we rushed it too.
Yeah. Okay, and then you have to use the like formula again.
Right. Now this one, the ratio r is a little bit harder to find. It's -7 over 8. Like, you get that from this. But it's so maybe I'm making this too complicated. It's -7 over 8, but it's to the n minus 1 power. But you have to start at 2 then. No, that doesn't give you that, does it? Okay. Well, yeah. So we're finding the sum. The sum is a1 over 1 minus r, and this is a1. A1 is 7/8.
Right. Okay. And it's also R.
So yeah, so A1 is 7/8, but R is minus 7/8 because that's the ratio between terms.
Oh, okay. So then 8/8 minus, or 8/8 plus 7/8.
So 7/8, yeah, and then it's 8/8 plus 7/8, so 15/8.
And then the 8's cancel on the bottom.
Yep, and you get 7/15.
Cool. Okay. That makes sense. And then like 36, you just have to like, you have to, I don't know what the pattern is.
Do you want us to go through 36?
Yeah, sure, because it's like, I don't know. That's weird.
36. Yeah, it's we have to come up with a formula for that. Just interesting.
It looks like it's like going, it's divided by 5 on the first one, but then it like goes to like 3s. So I don't.
Yeah, so this one is this one this is one of those things, like when you have the experience, you know what to do. We can make this like if you look at this part over here, we can figure out this sum, and then we can just add it to these over
Okay.
on the left. So the one on the left is whatever it is. We'll calculate that, but we need a formula for this. So it looks like it's 3/5 to the n minus 1 power. This is n equals 1, n equals 2, n equals 3, and so on.
Why is it the n minus 1 power? Isn't that when it's alternating though?
That's if there was a negative in front.
Oh.
So another way to do this, and I think this might even be better. Let me undo some of this because I think this is still unclear.
3/5 to the n though? I don't.
Well, that's where I was going to go. So if we do that, it's just this, and then we have to make this one.
Oh, because you start at 1. Okay.
Yeah. So it's playing around with these indices, which it's
So
very
if it was -1, would it be +1 and +1?
only if it was alternating. Depending on where it alternated, you could do that.
Okay.
Okay, so see if you can come up with the sum of this on the right here, and it's a1 over 1 minus r.
Am I starting with 3/5 or am I starting with 1?
I would start with 3/5. To me, this is a1 is 3/5 over 1 minus 3/5.
Okay. Three over 2.
2/5, yeah, 3/2, and then you just add the rest of this.
Okay, so 25 over 9 is 5/3. So you have to make a common denominator between all those.
So let's use nines. So it's 25 over 9, and then 15 over 9 plus 9 over 9.
Well, you have to multiply the 3 over 2 also, right?
No. Oh yeah. I guess you do. I was just gonna get these first and then see what it came up to. But
Oh,
if you have a calculator, you just put them all in, and that's another. This is
I don't know
49
if
over.
she's gonna give us a calculator because she
Okay.
told us it, so I'm kind of.
So then it's now 18, and you multiply this by 2, so 98 over 18 plus multiply this by 9, so it's 27 over 18. So 125 over 18.
Okay.
Is your final on that one?
Okay. Just look for the pattern. Okay, cool.
Yeah, I wish there was more of a recipe for these, but these are series or sequences, and then when they followed by series, there's a lot of things you can do to manipulate them, and like there is no one formula for everything in 36.
And then if it's less, so if it's these are all if it's less than 1, right? Or no, yes, less than 1. If it's greater than 1, it diverges.
Yes.
Okay.
Yes. All right. What else would you like to work on today?
So
Where should we go next?
we did this page. We did this one. There are some more limit ones. Okay, so on page let's see. Page is this. 546. It's like the very beginning of chapter 10.
Okay, I'm just going up. 546. Yep, got them there.
Okay, so I already did I've done 35, 42, 45, 46, 47, but we can do any of the rest. So like 37, 39, whatever.
Yeah. Okay. So like 37 is CN. I'm sorry. Yeah, equals 1.01 to the n. Is that what you're that
Yes,
one?
that one.
Okay. All right, snipping it in. All right. So this one is just trying to figure out what happens as n gets large. It's asking what is the limit as n goes to infinity 1.01 to the n. Okay.
Okay.
So this is essentially like there's a definition. If well, I don't know how to say this. If x, okay, so there's some things in here. Let me like trying losing words here. It's something to the power of n. If x is greater than 1, this diverges. If 0 less than x less than 1, it converges. So because this number, this is a growth model. If you were to graph it, it would very slowly, but eventually would go to infinity.
Okay. So
And there's
if it was negative 1.01 to the n, it would be negative infinity, right?
yes. Yes.
So it diverges then?
Yes.
Okay.
All right, so here the limit as n goes to infinity, b sub n, it's really two things. Or it's really a composition of things here. So sorry, those things aren't the you can really just find the limit of this part and then you take e to it.
Okay.
So the limit, you really just, this is really the limit as n goes to infinity 1 minus n squared. So what does this go to? So you can look at a graph. 1 minus n squared looks like this.
How
So
would you do it if you didn't know what the graph looked like?
you couldn't. You'd have to put bigger and bigger numbers in and make an educated guess for it.
And then what about the e?
So now we're saying what's the limit? What we're really doing, and this is incorrect, but it's e to the minus infinity. And that actually is 0. Now we could talk about that a little bit. It's 1 over e to the infinity, which is 1 over a large number. Some instructors do this, 1 over infinity.
Yeah, 1 over big. Okay.
Yeah, and that goes to 0. So sometimes the intermediate part goes to a thing you don't like, but the final part does. And e
Converges.
This one converges to 0.
And
yes.
then you would write it as like limit n approaches infinity of that function e to the 1 minus n squared equals 0, right?
Yeah, like, but this whole path here is the work. But there's really almost more words to this than like the path. All the stuff we just did here, that's how you show your work.
Right. But I think she just wants to answer in like limit notation.
Yeah. So you're taking this answer and you're putting it back here.
Yeah. Okay, maybe we can do like 50 or like one of those on the bottom. Yeah, 50. Let's do 50.
50. Okay. All right. 50. Okay. So limit as n goes to infinity, b sub n. So really, it's what's going on in here. What is going on there? So really, what we're trying to do is limit as n goes to infinity, 1 minus 2 over n. So this is 1 minus 2 over infinity. You shouldn't write this, but this is how you should interpret it. And 2 over infinity is 0, so this goes to 1.
Oh, okay.
Okay. Some instructors want you to use properties, but so we know that this part right here goes to 1.
But then tan inverse of 1.
So this is how you would write it. You would say, because of what we just said, we said this is equal to the arctangent of 1, which is pi over 4.
Oh, and you just know that from like from the unit circle.
Yes, you have to know your unit circle. So that's why I made a comment earlier, like students struggle because they eat all this algebra you learn, all this trig you learn. You have to like know it. You know, I'm snapping my fingers. Don't know if you can hear that, but you're got to be that quick. So it's usually not the calculus that holds you back in calculus. It's the algebra that goes.
And how do you do tan inverse on the unit circle though? Because isn't tangent is x over y, right? And
Yes. Arctangent is, but you have to know where it's defined.
is it just like the on like the other side or whatever?
I'm going to snip it in here, but let me just get to where I can do that. I was doing this for a student yesterday. It was really helpful. So arctangent is only defined. Let me get this. Arctangent is only defined from here, but this is minus pi over 2. This is minus pi over 3. This is minus pi over 4. And this is minus pi over 6. So you're asking, when you're trying to find the arctangent of 1, you're saying the tangent of what angle equals 1. And you know that this is square root 2 over 2 over square root 2 over 2. It's y over x. It's sine over cosine.
Oh, it's y over x. Oh,
yes, it's that one there.
But how do you know that it was that point, that it was the root 2 over 2?
That's the only one that makes 1.
Oh, you have to make one. Okay, I see what you mean. Okay.
All right, is there anything else here we can go through?
One of the, okay, so page 615, we might have like time for like one maybe. Not 7 or 14, but any of the other ones.
You said not 7, not 14.
Yeah, if you eliminate the parameter ones.
Okay, I'll just do 12.
Okay.
These are all a little different because they all emphasize different things in terms of like the algebra that you're doing. But basically you solve one of them for t.
Right.
You pick one and you solve for t. And then you put in the other. So like in this one, I'm going to solve this one for t. X equals.
Well, wouldn't it be easier? Oh, but you want it in the y equals form, so that's why you said.
Yes, yes. So it's generally that one, if you can. So this is x minus 1 equals 1 over t. And you can cross multiply here, so you get t times x minus 1 equals 1 times 1. T times x minus 1 equals 1. T equals 1 over x minus 1. And then it's given that y equals t squared. So you take this.
1 minus 1 over x minus 1 squared.
Yep. And then you can write this as 1 over x minus 1 squared if you really want to.
You shouldn't like FOIL the bottom or anything?
No, generally no.
Okay, cool, awesome.
All right, well, let's end here. I know we got another scheduled lesson tomorrow night. Is that right? Or
Tomorrow night.
yeah. Okay. I'll send you the notes and the screen recording out shortly.
All right, thank you.
Thank you. See you next time. Bye now.
Bye.